Objective: to learn about different types of phyllotaxy in leaves. A large variety of plants are present around us. In a China rose plant, we can see that leaves are arranged in 5 rows. Hence it is known as pentasticus. Each leaf arises from a node present on the stem. Let us represent the plant schematically for a better understanding. If we join the bases of the successive leaves, we find that the line gets oriented in the form of a spiral. This imaginary spiral line is known as genetic spiral. We observe that the 6th leaf is positioned over or overshadows the 1st leaf. Thus, the leaves are arranged on the stem in a definite pattern to achieve optimum sunlight. This pattern of arrangement of leaves on the stem is called phyllotaxy. Thus, a China rose plant shows a pentasticus type of spiral phyllotaxy. In Ravenella madagascariensis, the leaves are arranged in 2 longitudinal rows or ranks. But on the opposite sides of the axis, we find that the 3rd leaf stands over the 1st. In the schematic representation, the imaginary spiral line drawn from the 1st leaf has to make one complete turn to come to the 3rd leaf. Such a type of phyllotaxy is called 2-ranked or disticus type of alternate phyllotaxy. However, Cirpus microcarpus bears leaves in 3 ranks on the axis, thereby providing an example of tristicus type of alternate phyllotaxy. Here again, in the schematic representation, we see that the 4th leaf stands vertically over the 1st one, and the genetic spiral makes one complete turn to reach that leaf, linking 3 leaves in between. In guava, if we observe a twig with leaves, we find that 2 leaves arise from a node, and its schematic representation will show that the pair of leaves on successive nodes are arranged overlapping one another. This type of arrangement of leaves is called opposite superimposed phyllotaxy. In a calotropis plant, 2 leaves arise from each node, and the pair of leaves on successive nodes are at right angles to each other. In the schematic representation, we can see that the pair of leaves on successive nodes are at right angles to each other. This type of phyllotaxy is known as opposite dicasiate phyllotaxy. If we now look at the nerium, we find that each node bears more than 2 leaves. If we represent them schematically, we can see that they are arranged in a whorl. This is called whorled phyllotaxy.